So as we start looking towards electric propulsion, so the ability to distribute lift, we then started looking at other configurations. So one of them we announced actually right before Verticon was the Rotor Blown Wing, which looks like a flying wing with 2 helicopter rotors in it. And it looks that way because, well, that's what it is. And it combines a lot of qualities of a helicopter in sort of the slow, constrained flight. It's very maneuverable. It can also operate off ship decks and high sea states. And then when it gets up on the wing, it flips onto the wing and flies pretty much like a fixed-wing aircraft, or a flying wing in this case.
Yeah.
Welcome to Hangar X Studios, where former fighter pilot and host John Ramstead takes us on a journey across aerospace as it enters an historic period of innovation and transformation. Our guests include aviation experts, pilots, financiers, military leaders, and innovators of all types. Buckle up for another episode of Hangar X.
All right, welcome to Hangar X Studios podcast, and we are live at Verticon, and this is the place where we get to talk to disruptors and innovators and people that are actually making the changes in aerospace and vertical flight that we're going to be talking about for years, and we get to get that information before the rest of the public does. And with that, I'm really excited today to have a conversation with Igor Cherepinsky. Igor, welcome to the podcast.
Thank you.
It's great to have you here. Now, you are at Sikorsky, and you're the head of the innovation labs, and we've been able to have a couple conversations leading up to this, and I've been just blown away with not only your brilliance, but your insights into the work that you're doing. So could you first of all talk a little bit about kind of your background and what led you up to what you're doing at Sikorsky and the innovation labs?
Yeah, sure. So my background is actually flight controls engineer. I was an electrical engineer. We're working a lot of flight controls algorithms, handling qualities, autopilots, things like that. I always loved flying. I got my pilot's license early, started on sailplanes and on various things. So aviation...
And you've looped a sailplane.
I have looped a sailplane.
Yes, you have.
In general, aviation is near and dear to my heart.
Yep.
And helicopters are really, really cool because of the life-saving mission. So I started working Sikorsky almost straight out of school and stayed because it's just a really neat mission.
Yeah. And now you've done a number of jobs coming up through Sikorsky. And when you were brought over to the innovation labs, tell us about what's the purpose of it and what's its mission right now.
Sure. So, as I said, I was working a lot of flight controls work, and then as Sikorsky was looking towards its future, they actually set up Sikorsky Innovations, which was back then modeled on Skunkworks. It was obviously prior to us joining the Lockheed Martin family, and they were looking at what's next. And one of the things that was next was autonomy, the broad word, and no one really knew what that meant. So they picked me and said, hey, go build a team, let's figure out what do we mean by autonomous flight. And that's how I started my career in Sikorsky Innovations. And then over the years, I have the privilege of leading the whole group.
Yes, you do now. And what are some of the big things you've developed? If you look back, you go, wow, you know what, our team figured that one out.
Yeah, so obviously one of the big things is X2. I know everyone has seen it, right? So it's the fastest helicopter in the world. The early prototype is now in the Smithsonian, and we're going to have several aircraft flying. There's other really cool things that, innovations developed before it was called Sikorsky Innovations. So S92, for example, was developed by my predecessor, who was the founder of Sikorsky Innovations, but before that, he ran the advanced design group at Sikorsky.
Okay.
And S92 is a great aircraft. We've done a number of, flight controls enhancements and flight control systems. There's been things like additive manufacturing. There's a wide variety of things that now are flying on, Blackhawks and 53Ks.
Well, and also, you guys also developed the stack that allowed you to remotely fly a Blackhawk.
Well, of course. And then there's the big one is Matrix, and I'm going to correct you. It's actually not remotely flying a Blackhawk.
Okay.
As much of fun as it would be to remotely fly a really large helicopter, you don't fly it. You kind of tell what the mission is and it flies itself, which is a big difference.
Oh, really? So it's... Tell me more a little bit about what's the difference there? I'm just curious.
Well, so the difference there is if you think about a remotely piloted aircraft,
right?
Let's start with RC models, because a lot of the quote-unquote drones, or whatever you call them, right, grew out of a hobby of RC airplanes.
Yeah.
Which, again, myself and pretty much actually everybody on my team does.
Right.
Right? So it looks like a little RC controller, pretty much looks like cyclic and collective if you fly an RC helicopter and you fly it.
Yeah, the remote control.
Yeah, so the normal RC helicopter and airplane, right, you fly it with a remote controller and you remotely fly it.
Yeah.
You're not in it, but the physics of flight is pretty much the same as a normal airplane.
And is that kind of almost a similar translated to the Air Force, like with the Reaper and the Predator?
Yeah, that's my understanding. That's what they, let's say, did yesterday and maybe doing today, although that's moving on. But again, you have a remote pilot who's sitting in a remote cockpit, doing all sorts of pilot things.
Right.
So the difference of what we did is actually say, okay, that's great, but if I want to, let's say, move cargo, and I have an army logistician who really couldn't care less, quite frankly, that's a helicopter. His job is to move something from here to there.
Yeah.
How does that person operate an aircraft? And it's a completely different thing, right? They have a tablet and they have like a list of stuff, and they move this stuff. So they tell the aircraft, there's a piece of cargo over there, go pick it up and bring it over here. And the aircraft figures out the rest of it.
No kidding.
Yeah. So it's boring, which is the way it's supposed to be.
But that's what Matrix does.
Yes.
Allows that to happen.
Yeah. Or on the civil world, when we, and we have actually parts of it flying us night too, like a rig approach. The pilot will say, I need to get to that oil rig.
Yeah.
And our current version of the autopilot will take you close to a rig. Our next versions will actually lend you an oil rig, and you just kind of sit there and watch it do its thing.
Wow.
And it has sensors that's going to make sure that you don't hit anything, that you're going to land on the right rig.
Yeah.
Because believe it or not, sometimes we have overworked pilots that end up not quite on the right rig.
Yeah. Now, at Innovations Lab, you guys have also embraced VTOL, vertical takeoff and landing. And kind of what's your vision of that space and the work that you've done and how it applies to a lot of transformations that are happening?
Yeah, sure. So again, Sikorsky is not just a helicopter provider. If you go back to Igor Cherepinsky's vision, it was really vertical flight in all its forms.
Mm-hmm.
So we constantly look at what aircraft configurations make sense for us and our customers and our missions. So as we start looking towards electric propulsion, so the ability to distribute lift, we then started looking at other configurations. So one of them we announced actually right before Verticon was the Rotor Blown Wing, which looks like a flying wing with two helicopter rotors in it. And it looks that way because, well, that's what it is. And it combines a lot of qualities of a helicopter in sort of the slow, constrained flight. It's very maneuverable. It can also operate off ship decks and high sea states. And then when it gets up on the wing, it flips onto the wing and flies pretty much like a fixed wing aircraft, or a flying wing in this case.
Yeah.
So that's one of the versions. We're looking at other versions of distributed propulsion and seeing how that's going to bring better value to our customers.
Yeah, and I got a question on the Rotor Blown Wing. So I've now you guys have recently announced that there's been like 40 takeoff and landings and 30 transitions. And I'm just thinking about the flight control laws that you had to develop to make that transition happen. I'm guessing that's a lot more complex than it looks just observing something that looks like it's smoothly transitioned. So
yeah,
I'd love your insights on what's really happening there, whatever you can share.
So obviously the fighter pilot, you appreciate that you are starting with a wing that happens to be at 90 degrees to an airstream, or at least to an apparent airstream. So there's some very interesting aerodynamics happening where we call it rotor blown wing.
Yep.
Because we're using the rotor to blow onto that wing. Again, that's not new, by the way, right? There's been lots of blown wing aircraft. But then the trick becomes, so how do I come off the helicopter rotors, get onto the wing, blend the fixed wing control surfaces with helicopter controls? And by the way, maybe don't even have fixed wing surfaces. We're looking into that, but I can get away with nothing but the helicopter controls and make it simple. Okay. And then how do you flip that aircraft in a stable manner and come back? And yeah, it took quite a bit of work and wind tunnel modeling before we actually tried this.
And you aren't doing this. These aren't traditional propellers. These are actually helicopter rotor blades, correct?
So it's an in between, right?
In between, okay.
It's a prop rotor.
Okay.
Again, that part is not new. There's other vehicles that have flown before us that have done that. So this balances performance of a helicopter rotor in edgewise flight with a propeller that obviously flies like an airplane propeller.
Yeah. So what was more challenging for your team? Was it the transition to horizontal flight, or transitioning back into the vertical flight stability so you can land, let's say, on a back of a destroyer?
Yeah, it's a great question. So enough, the aerodynamics, you would think it's identical.
Yeah.
And it sort of is. But again, I'm sure you've seen where a stall happens.
Yeah.
Actually varies quite a bit whether you're getting on the wing and getting off the wing. So there's lots of nonlinearity. So we had lots of conversations on, so what's going to happen if we get on the wing, we're flying around, and we try to get off the wing, and it doesn't work?
Yeah.
And the answer was, well, let's go see it. There are differences, and the flight control system and really the autonomy system accommodates.
Yeah.
The neat part here is that unlike other vehicles that have done purely with flight controls, we do loop in our autonomy and planning system. So the thing that plans the motion, a thing called motion planner, that normally pilot would figure out what the trajectory is.
Right.
And here the aircraft does.
Yep.
So we actually plan it in there to say, well, how would I transition? Where are all my limits?
Yeah. And question for you now. When we were talking yesterday, you made a statement I thought was interesting. You said, autonomy and the software that's in the VTOLs is 10 times more important than the power systems, because we were also talking about, hybrid electric or pure electric and things. What makes autonomy such an important part and really the future development you guys are looking at?
So again, the word autonomy is a gigantic overarching.
It is a big word, kind of a buzzword. So maybe you can break it down for us a little bit.
So if you look at least what we are doing with electric or hybrid electric propulsion, right? The reason why we'll start with hybrid cars, right? The reason why automotive industry went there is because they realized they can do all sorts of interesting power management, right? You're familiar as you're driving a car, your viewers. Power requirements are different. Climbing up the hill is very different than descending from the hill.
Yeah.
So hybrid cars take advantage of that. So we looked at rotorcraft or vertical flight and we said, well, obviously lots of parallels. We can play with energy states. So that's more than just the hybrid system. That is to say, yes, we're building motors and actually building triplex redundant, super reliable motors with power electronics. That's all really cool and important.
Yep.
But tying that to the flight control system and then ties into the really motion planning system that forms our autonomy stack and a mission planning system. So the entire aircraft understands, here's the mission I'm about to fly. How do I manage energy? It all permeates that. Enables a lot of neat things to happen because I can plan for things.
Does the hybrid electric and the way that the electrification to electric motors give you more design freedom than a traditional power plant with transmissions and things like that?
Yeah, so another great point. Again, today, most of the rotorcraft you see here are really designed around the turbines, let's be honest, right? We all pick the best turbine we want. We look at the speed it wants to run, and we design a drive system that optimizes all of that.
Yeah.
That's a little limiting because I can usually run at only 1 RPM, and there's some very narrow places where you want to be for efficient flight.
And there's a lot of weight and a lot of design constraints around that.
Correct. And weight is a funny thing, right? We usually don't tie weight because when people think electric, they think heavy. And unfortunately, that tends to be correct if you don't do it quite right.
Well, the hybrid electric allows you to have a smaller battery pack. So there are some good trade-offs there,
smaller turbines.
Smaller turbines.
So depending what you're trying to do, you basically can pick where you're drawing your energy and optimize the vehicle for that. So we even looked into, again, that's why we're talking about a family of system. You can have one aircraft design, but depending on the customer, they might want a smaller turbine and bigger battery pack, or the other way around, depending on what they want to do with that aircraft or how they are going to run it.
So, talk about the rotor blown wing. What does it look like in 5 years? I'm guessing there's going to be a family from small autonomous to something larger.
Absolutely. So obviously, again, Sikorsky is super into continual life-saving missions.
Yep.
So if we look at firefighting and other places where a persistent VTOL UAS can help, rotor blown wing was designed for that. So we see these aircraft operating with firefighters right on the front lines, taking off and landing right beside our Firehawks, helping them. As you scale these vehicles up, at some point we do want to carry humans because, again, right, Sikorsky has been proud for carrying humans for many, many years. Humans have this funny thing. They really don't like to be flipped 90 degrees once in a while. So we're going to have to put a fuselage on this aircraft.
Okay.
And, if you haven't seen pictures, we can share pictures with what we think our future, winged VTOL looks like. And that
you have the model over here, but that's the kind of the unmanned version.
That's an unmanned.
I can see that larger with passengers,
yes,
right?
Larger, more comfortable seats, nice plush captain chairs on a vehicle that can take off and land like a helicopter and then carry you for quite a distance.
Yeah.
Or cargo, by the way, right? Same thing.
Same, yeah. Now, question for you is I'm guessing there was probably 1,000 engineering challenges to overcome building this. Is there any 2 or 3 that rise to you know what? That one we're really proud of. That was a big challenge and took a lot of work
there's a couple. So like I said, one was figuring out how to make highly reliable motors, right?
Okay.
Because in a helicopter,
you developed those in-house?
We developed those in-house, right? Our team developed that. And again, they're 10 to the minus 9 per flight hour, which is a gold standard for reliability.
Yep.
Because of how we want to use our vehicles, we're looking at, 2 prop rotors. So obviously having one of those stop is not an option. Nothing really good happens.
No.
So we want to make sure that drive systems are reliable. So that's one of them. The other one is getting away from conventional manufacturing methods.
Oh.
So if you think about, modern helicopters, and again, all of us here in the industry have to live with this, gearboxes, gears are typically, cast, forged. That is a long and expensive process. That actually drives a lot of design time and lead time. We are now 3D printing our, gearbox housings. We're 3D printing our gears.
And what's the durability of a printed gear?
It's actually just as good as a cast or forged one.
No kidding.
Yeah, when done right, except the lead time is way lower.
And is it certified?
Not yet. So
But that's also something you're working on, I'm guessing?
that is a goal.
So it's a whole new manufacturing process that can benefit
Very
the
much so.
industry.
Very much so.
Wow.
Different way of making airframes. Again, right? You're getting away from the standard aluminum or just standard composites, more into things like thermoplastics,
Yeah.
more automotive-like assembly lines, much more, robotic manufacturing.
Yeah. So as you're looking a year or two ahead, what are you most excited about?
So that model you saw, that's a small scale model.
Yep.
We are in the process of building our large 9,000-pound aircraft. That is that.
Yep.
Step one is this year we're going to complete our power systems test bed, which is a fancy word for we took all of the stuff from inside the aircraft and said, hey, let's put it on this thing that looks like two trusses, and we're actually going to fly it around and hover around that.
Okay.
And we're doing that because we're going really, really fast.
Yep.
We're not sure it's all going to work according to plan. So should something happen, I'd rather not lose a nice airframe. So airframe's going to sit there and wait for 6 months or so for us to finish this early flight testing, and we're going to take.
But that does fit your mission of rapid prototyping.
Oh,
I
absolutely.
mean, that is your DNA at
That's as
Innovation
rap
Labs.
as it gets.
Yeah. Okay, so that's one thing you're really excited about. And let's just say, my goodness, 10 years from now, you're looking back, right? This is kind of an exciting, I think, time in aerospace.
Yeah.
What are some things, if you put on your kind of your futurist hat, some things we might be talking about 10 years from now?
10 years from now, we'll hopefully have a couple of, real products and service certified with the FAA or actually with our military customers.
Military and civilian, or more military focused?
So we are equal opportunists, if you will. We love our customers on civil side, the military side equally.
Yep.
And interesting enough, we looked at a lot of the missions that have huge amounts of overlap.
Yeah.
If not, some of them are identical. So we're going to go design vehicles that have utility in both.
Yep.
And we're looking forward to both our customers flying these aircraft in 10 years in their missions. So hopefully we're here, and then walking you through a large, tilt wing and a nice single main rotor that's hybrid electric, that's, super comfortable for our VIP passengers and does a great job for offshore oil and other places.
Yeah. And I can, as a military guy, I can think of a lot of missions the military would be very interested in a platform like that. So,
Oh, yeah. So we're obviously talking to them about all of that.
I'm sure you are. Well, Igor, it was great to have you on. I'd love to have you back. And you have an open invitation here to come talk about anything you guys are working on, new milestones, new breakthroughs. So we'd love to just share that with our audience, which is loves the work you're doing.
Absolutely. Thank you.
All right. Thanks, Igor.
Yep.